Hello everyone, my name is Bogdan Diaconu and I'm a senior technical animator at Yager. I've been working in the game industry for about 12 years and I had the chance of working with various engines, Unreal Engine 3, Unity, Ogre Engine, and a few in-house engines. Yager is a very well-established Unreal Engine studio, about 16 years of experience with it, so it gives me the opportunity of developing my technical skills within using Unreal Engine 4. Also, it gave me the chance of working on Yager's first core mobile title. It's an undisclosed title, so it's not a lot that I can say about it. Nevertheless, what I can tell that we had a few prototypes in order to discover what we want and which direction we want to go. So we decided it's going to be a third-person view camera for the character. And also we looked into having various characters with different silhouettes. So yeah, taller characters, shorter characters, different proportion and length for the arms, for the legs, wider shoulder, narrower shoulder. And yeah, we discovered quite fast. We had some challenges. The main challenge came from having only 75 bones available to use for a skeletal mesh on a mobile. And when you have different characters that are quite complex, this 75 bones limitation will be quite impactful. And also the animation sharing, being a mobile title, we wanted to have as much as possible to use the same animations, even if the characters had different proportions. The previous projects that I worked with, if we had the animation sharing, then all the characters had actually the same identical skeleton, or when the characters were various, different shapes, different proportions, each one of them had unique animation set. Yeah, the first challenge, the bone count. As I mentioned, the maximum bone count for the skeletal mesh on mobile is 75. At the moment, it's a hard threshold. So if you exceed this count, the mesh is actually not displayed on mobile. So I'm going to have a short video showing what's happening. In the first part of the video, it's recorded from Pi, from the Unreal Engine on desktop. And the second part of the video, it's directly captured from the mobile device. So here, now we have the characters with multiple arms. And yeah, on mobile, that character disappears. The mesh is just not visible. So yeah, it's not going to help us a lot into presenting that character. For the prototypes, we used the mannequin. The man is, it comes from Epic. It's one of their free characters that you can grab from Epic Store. And here's how it looks like. It has, with the skeleton and the mesh. And what has something special that its character has, it has a separate hierarchy for the IKs. So basically, for the left hand, right hand, and the left foot, right foot, and also for the gun, you have a dedicated bone. It's on a separate hierarchy compared to the characters. Over here you see that we have the root, and after that we have the pelvis, and out of the pelvis all the character bones leave. But on a separate hierarchy we have the IK bones. So we have a root for each one of them: left foot, right foot, gun, left hand, right hand. This hierarchy is needed in order to pretty much replicate the IK rigging system from within your animation package, be it Maya, 3ds Max, Blender, and we get this. We can replicate this inside Unreal Engine. So yeah, we needed to find a workaround for this bone limit when dealing with more complex characters. Like in this case, we have some kind of centaur. So we can have multiple legs, multiple arms, even ponytails. And also you might have clothing for the character. In this case, yeah, a trench coat, which is over the knees. So in this case, just for the trench coat, you would need at least 4 bones to properly animate it when the character is running, jumping around. But if this trench coat would actually be under the knees, you would need even more bones to properly rig it. And that for sure will get you over the 75 bones count. And yeah, bear in mind that because of that separate hierarchy, we have already 7 bones are taken away from the 75 count. So something else we looked into it was having some kind of gadget for our characters, in this case, a robotic arm gadget. So only this one as well would take us over the limit. So how do we solve this one. We can implement a modular system. What does it mean? Basically separating the character in multiple parts. One part would be the base character, so just like the default many. A second part would be the gadget. And when they're both combined would give us the final result of something what we want. Something that is very important though, and has to be mentioned, is that the gadget pretty much has to have a shared hierarchy of bones with many, with the default, with the base character. So this means that here on the left side, we can see the hierarchy for many. So this, what's in blue, from root, the path from root to clavicle right, the same hierarchy has to exist on the gadget. So on the right now, it's the gadget. So we have the same paths: root, pelvis, stabilizer, spine 1, 2, 3, and clavicle. And after that comes the bones that we need for the actual gadget. The gadget, when it comes to how to add the gadget to the system, to the player, since it's a modular system, there are a few ways. The way that we went was to create an event function within the character blueprint. So what this would do would toggle the gadget on and off, because we wanted to also measure the performance. What happens when the gadget is on? What happens when the gadget is off? Is the performance better? Is it worse, or how much worse? So yeah, this is it's a simple setup. You add the skeletal mesh component as a child of your mesh blueprint. You add the skeletal mesh for it. You add the animation blueprint. And also, yeah, when it's toggled off, you just destroy the component. The other solution would be, of course, to just by default add it directly into the character blueprint as a child and set up over there the skeletal mesh and the animation instance. The gadget, as mentioned, the gadget will need its own animation blueprint. The main reason being that you want to copy the animation from the parent on the gadget, and that's why we needed that identical hierarchy. And to copy the animation, Unreal gives us this pretty awesome node, copy mesh from reference. And we can use it inside the gadget animation blueprint in the anim grab. So we have the parent mesh. From the parent mesh on the left, we can grab the animation instance. It's passed to this copy pose from mesh, which will just match the bones. That's why we needed identical hierarchy. We'll just pass the animation from the parent to the gadget, and we'll play absolutely the same identical animation. And on top of that, we can have a separate state machine for the gadget where we can play its own animations. So here we can see just a simple implementation, what we did. So we had an idle state for the gadget. So yeah, when the player is idling or just running around doing nothing special, and the gadget will just be in an idle mode. And likewise, if the character is using a ranged weapon and starts to aim, the gadget will fold, the robotic arm will fold, so it doesn't obstruct the player view. Or if the player has a melee weapon and attacks, the gadget will also do a melee attack. And here it's the end result, the melee, and now the gadget will fold when it's aiming. So as some conclusions, or let's say other conclusions, other solutions, first of all. So we could have the gadget as a fully separate object attached to a socket. So yeah, something like this. This one, in bottom line, this one would be the kind of the same system that you would have if you have weapons in your game. It's absolutely identical because weapons generally are attached to sockets on the hands, and it's very doable. But what's happening with like this, it takes a little bit more time and also might take some resources on the engineering side. So yeah, we decided to go for the previous solution. Another nice part of it, and it's built for scalability. So if you would implement it actually as a weapon, this will not work out as easily. So what do I mean by built for scalability is that, if you want multiple parts for a character, say that, as we saw earlier, you have a many with 4 arms instead of 2, or even more so, you want facial animations. Facial animations means a lot of bones on your head, and that will be way over 75, probably close to 100 bones. So in this case, you can separate all of them. And again, they will have to have the same shared hierarchy. So these extra arms, they have from root till the spine 3. And also you have the head separately with all the bones from it, and all the combined together gives us the final result. Basically, what you have in the end is pretty much 3 objects playing the same animation at the same time, with the opportunity of having each module can have its own animations. The second challenge that we had was coming from the fact that we wanted to share as many animations as possible. So what does it mean? So basically, we have these various characters with different proportions. If you want to create individual animations for each one of them, it's all fine. But for mobile, we want it to be as optimal as possible. So we wanted to have only one character animated. So this character in red here, the silhouette in red, which we call it a regular character. All the animations are authored on him. And all the other characters with various proportions will just have the animation taken from the regular using the retargeting animation at runtime, which is, again, a nice feature that Unreal Engine offers. So this one allows, it really takes from the animation team work, because they have to pretty much animate only one character instead of multiple characters. As we discovered, though, very fast, a few challenges when doing so. So generally, the challenges come from the fact that if the character interacts with something, you might not get the desired results just with the retargeting animations. So some of the interactions that are most obvious, of course, gripping the weapons, grabbing the weapons, and reloading the weapons. For the weapons gripping, especially for the left hand, so if the left hand goes under the barrel, in this case, it's an assault rifle, so that's how we hold the weapon. And if you have a character that's taller, longer arms, the left hand actually might go through the weapon, might overreach the weapon, so it's not going to give us the desired result. Or if the character is shorter, slimmer, you might not even reach under the barrel, so the character will not look, the animation will just not look nice. Likewise for the reloads, because reload animation, it's a lot of interaction with a weapon. You take your hand, you put it on the magazine, and again, if you have a taller, heavier character, it might not even reach the magazine, or maybe the hand will just go through the magazine, and again, you don't get what you want just with default retargeting. So we applied when you apply just the retargeting without IK, we used as a test, we had all the animation done on the character in the middle, the gray Manny, and we also had 2 different characters. I'm going to have a few videos next where these 3 characters will feature in. So the tall one is the one on the right. So he's a bit like half a head taller and a bit wider shoulders, longer arms. And the left one, the turquoise one, shorter, slimmer. And when we apply the retargeting, so the left character, the left hand it was going through the weapon, and the short one, likewise, the left hand is just not reaching the weapon even. It's quite visible over here. It's not grabbing properly the barrel. So the first step of the solution was to add the IK system that it's available by default in Unreal Engine. And this is where it comes. That's why we needed that separate hierarchy of IKs, so we can replicate the IK rigging inside the Unreal Engine. And when you do this, it's already better. The thumb was still not there. And for the slim character, it's slightly better, but it's still not there. So there are some solutions. So since we still didn't get the desired weapon grip, we thought about having offsets for the IK controllers. So that means pretty much going inside the animation blueprint of the character, selecting the node that it's quite like you would select a controller in your animation package. Here it's a node, you select it, you get a widget for your IK handle, and you can move the left hand around until it properly matches the barrel. Maybe the fingers don't fit, that means you need to add maybe an additive animation. And on top of that, you need to store those offsets somewhere, because you have different characters with different proportions. So you need, and also you have different weapons. In this case, it was just the assault rifle shown, but you might have SMGs, hunting rifles, who knows. So in this case, we had a special table where we store these offsets per weapon, per character. It's doable, it works, but it's a higher maintenance. It involves engineering, since they have to create this system, the table system. You need a way to store these offsets, so those tables, and it has to be manually configured. So you need the person, the technical animator, the animator that has to go, and then the animation blueprint, and has to go through all of that and find the offsets and manually enter them in those tables. But we noticed after a while that there is another part of the solution at the modeling stage. So the solution was just to have, let's call it an universal hand. What does it mean? So you have the hand that was on the default character, and this hand pretty much has to be used, the mesh and the skeleton identical on all of the other characters with different proportion. So pretty much duplicating, like you would duplicate the hand, mesh and skeleton, and just attach it to the other ones, to the other characters. So what we want, what is needed basically is having the same distance between the wrist and the start of the fingers has to be identical or very, very close, because some characters might have thicker fingers, or if they have gloves, so you can spread the fingers a little bit, but not quite a lot. And it's very important also to have the same length of the bones inside the fingers. So yeah, when we do this, now you can see the heavy one was grabbing properly the weapon, and the slim character likewise is properly grabbing the weapon. So yeah, as conclusion, the character, they all have to have the universal hand. The costs will be on modeling, so it's freeing the engineering and potentially the animation team on having to do a lot of work. And also when it's on modeling, it might actually speed up the process a bit, since you have a universal hand, we just move between the characters, or you can have like a set of them, like a thicker hand, thinner hand. But yeah, it's not always possible to share animations, because sometimes you want dedicated animations, but generally the fewer the better. And also, like one case would be you have a very tall character. So in our case, the difference in heights was like half of head. But if you have a giant, say a 4-meter tall character, if you take the hand from the short one, from the default character, and you put it on this very tall character, it might look a bit silly. And likewise, sometimes you do want to have dedicated animations. Maybe if one of the characters has a super cool move, then it's just that character that you'll use. Of course, in this case, animation sharing is not going to work out. You need dedicated animation for that special cool move. So this one was the main challenges, but nevertheless, there are a few extras, some things that we also discovered. One of them was using procedural animation in certain situations. So basically, here it's one of the cases would be having ponytails for a character. Like, these are actually really ponytails, what you see here. So what do you do when you have this type of things? You can have ponytails, maybe you have like a few weapons on the back, and you want to have some nice animations on them while the character is moving and just not be stiff. And how do we do it? One way would be, of course, not using animation sharing. So that means the animation team has to go and take all the animations and animate these separate parts. So the ponytails, the weapons on the back, animate them separately, which can take quite a while, depending on how many animations you have. You might have like an animation set with 100 animations. Doable, but it's not really heavy. It's a lot of work. Some extra stuff. So the solution would be to use procedural animation in the engine, because Unreal Engine offers that. So pretty much you do this by using the Anim Dynamics node. So you can pretty much think of it like setting up some type of simulation within the engine. It's a cheap node. It's very performant. I think these days there might even better nodes than this, but this is what we used. So you do the setup within the animation blueprint. And when doing so, it's a win-win situation, because you can still share the animations, and the animation team will be extremely happy. They don't have to do all those animation again just to animate these extra parts. Some other thing to consider is performance. So on mobile, maybe the animation is not the one taking the most from the performance. So there are the number of triangles, probably it's one of the areas that it's rare where the mobile device might struggle, or some other things. But nevertheless, you still want to pay attention to performance and make everything counts for mobile pretty much. So one way to do this is to have the fast path enabled in the animation graph. So quite for a while, I think before 4.10, Unreal Engine offers this For each node, for most of the nodes inside the animation graph, we see this in red, lightning bolt that can appear on your node. That means you have the fast path enabled, and that means the animation graph is evaluated faster. And when you don't have this, like in this case, so in this case, those lightning bolt is gone, the fast path is disabled. It's not the end of the world, but nevertheless, every bit of performance counts for the mobile title. And in this case, for example, the fast path was disabled because we did this calculation here for the variable. We had a blend IK variable. And just this simple thing, because it's a conversion from bool to float, broke the fast path disable. So even if it seems like something very minor, just a conversion from one type to another, do all of this, not in the animation graph, but in the event graph. You want to do everything there and just have one variable that can affect alpha in this case. Another thing when it comes to performance is using this tool that Unreal offers, the profiling. So this tool basically allows you to see if you do something on your animation, you have a new node on your animation blueprint, you can evaluate and see how much that node affects performance. So for example, when you did anim dynamics, we looked into see, hey, these 4 nodes, how much will they take? And yeah, we saw that it was taking about 0.02 milliseconds from the tick, which was fine. Another case where we used this tool was when the subanim instance feature was introduced. And we wanted to take some, because we would have one animation blueprint for all the characters with different proportions. Each one of them could have various parts that don't exist on the other characters. So in this case, we separated on different blueprints those anim dynamics nodes, and this sub-anim layer offers you this. You can dynamically load those anim dynamics based on which character is using the blueprint. And again, we wanted to look into the performance, how will that impact? And again, we saw that it was a minimal impact. And yeah, this actually, the sub-anim layers is pretty nice because maybe some characters actually don't need the anim dynamics. So in this case, we don't have anything loaded. So again, a bit of gain in performance. So in order to conquer these challenges, I watched a lot of talks, and these specific ones from Epic helped me a lot. Because, for example, this one, one-type animation retargeting from Laurent Delayan, this one covers a lot more about animation retargeting, and I totally recommend it because I couldn't cover a lot when talking about that. And making the most of animation blueprints from Kay Vasey. This one, again, it's a really, really good one, showing a bit how they did it at Fortnite, and I was very inspired by this. And also the animation blueprint I set up walkthrough stream. It's a series, I think 5 or 6 videos from Jay Hosfeld. And it's really good from beginners to advanced, showing different tips and tricks when working with animation blueprints. So yeah, that was pretty much all. Thank you for your time, and let me know if you have any questions.